Hello friends, good morning. Today we will see the topic on traveling salesperson problem. Okay. Now see this. One vehicle is traveling from different places. Assume these all are different places. Okay. Assume this one is a postal van. Okay. Now consider it is as a postal van. So this one is a post office, this is different places, or a postal box. You can consider this one is a box, this one is post office. Okay, we'll study regarding this problem, how this problem will work and how we will calculate this problem. Okay. Now this problem finds application in variety of situations. Among that I am considering this postal van. Okay. We have to route a postal van to pick up mail from mailboxes located at n different cities. So n different cities. Here n plus 1 vertex can be used to represent a situation, and one vertex represents the post office from which the postal van starts and to which it must return. In traveling salesperson problem, a person can travel from one place to different places, but he has to come back with original place. See, this person can visit to this node and this node, city. You can assume these all are cities. So this city, after visiting this city, he has to come back to his home. That is aim. Okay, so must return to the original place. To return and to go to from one place to another place, how will I identify? So that is an edge. Through edge we have assigned some cost. Okay, assume this one is one place and this one is another place. From this place to this place, how you can judge, how much far away from this place to this place? So you'll obviously go per kilometer, right? So that is called distance. So that is called cost. In our technical term, we will tell this one is cost. That's it. So this cost, how to connect this city to this city via road, na? So in this road we can call nothing but cost. How much cost? Using which one? Edge. This is called edge. Connect from one place to another place, we can call edge. Okay. The route taken by the postal van is a tour, and we are interested in finding a tour with what? Minimum cost. We have to find the minimum cost. So let's see this minimum cost. In this example, postal van starts its journey from original place to another place, from this place to another one, this place to another one, and return to the original place. Is it clear? Return to the original place. Now from this place to this place there is a connection. Yes, that is called what? Edge. This is called what? Edge. Which how much kilometer? 3 kilometers. From this place to this place, what is the cost? 4 or 4 kilometers. From this place to this place, what is the cost? 2 kilometer. Okay, and from this to this, what is the cost? 6. And these all are also intermediate nodes, or what is having the values 9 and 8. Our job is to find the minimum path which this vehicle can travel. Okay, that is called traveling salesperson problem. See here, from P to Q, how much? From P to Q, distance is 3. From Q to S, how much? Distance is 4. From S to R, how much? 2. Distance is 2. Then R to P, what is the cost? 6. Now add these values. 3 plus 4, 7 plus 2, 9, 9 plus 6, 15 is our minimum cost. This is our job, to find the minimum cost, okay, given cost matrix or diagram. Is it clear? So now we'll see further details. A graph G, that previously what we have seen, that is called graph, where V is a set of vertices and E is a set of edges, and assume that source vertex is 1. Assume that what? Source vertex is 1. So a tour is defined as simple path that starts and ends at source vertex 1. Now see here, there are 4 cities named 1, 2, 3 and 4. 4 cities are there. This is our source vertex, means person can starts his journey from this place. So this is called our source vertex. He can travel from this place to this place. After visiting this place, he must visit this place. After visiting this place, he must visit this place to this place. 2 conditions are there. That person must visit all the places without fail. Okay, I repeat, that person must visit all cities and return back to his original place. This is a condition of TSP problem. If this person can't escape node city 4, okay, he must visit 2, 3, 4 and return back to the original place. Okay, that's why tour may starts from any of the edge. Person not only just starts with vertex 1, the tour it can take node 2 or 3 or 4. You can take any one vertex as a source vertex. Okay, not only compulsory, you will not going to take only one. You can take either 2, 3 or 4. There is no restriction. Okay, so in this example we are considering source vertex as 1 and it must starts and ends at where? Vertex number 1 only. Okay, now a small formula we are going to use. g of I comma s, let g of I comma s be the cost of shortest path starting at vertex I. Just a minute. Generally we can use this formula we can call as recursive function. Okay, so here yes I is what? So I represents row and j represents columns. Okay, now C of ij, cost of ith row j column. This is cost matrix. Cost matrix is what? Ith row and jth row, sorry, jth column and ith row. Now you understood this I is nothing but row. Okay, what about s? S is stages, S is subsets. Okay, minimum g of j is nothing but column. This j belongs to this s only. For example, I can write here g of 3 comma 4. Now what is the I value? 3. What is the s value? 4. But what is the j value? J value is also 4 here. J value is also 4. Mean j belongs to s. In next example we will come to know what is s and what is j, how we can take these two values. Okay, but you remember this formula in TSP problem, traveling salesperson problem. Okay, now the problem will give like this: directed graph or cost matrix graph, or both they will give. If they given this graph, you have to draw adjacency matrix, cost adjacency matrix. Now this is a C and these represents I and these represents J. So cost matrix per of this graph 1 to 2, 1 to 2 they have given some cost 10, and 1 to 3, 1 to 3 they have given 15, 1 to 4 20, 2 to 1 5, 2 to 2 0, 2 to 3 9, and 2 to 4 is 10. Like that they will give. Here we have to find the minimum path. Consider any source vertex, any one vertex as source vertex. In this example we are taking 1 as our source vertex. This person can travel vertex 2, vertex 3 and vertex 4 and return back to the vertex 1. Okay, understood this problem? Now we'll solve. See here, 1 is what? Source vertex. This source vertex can travel vertex 2, it can travel vertex 3 and vertex 4. Okay, now another situation will come. these two vertex may travel two vertices, I mean 2 to 3 and 2 to 4. Similarly, third vertex also, it may take a journey from 3 to 2 and 3 to 4, but source vertex is what? 1. Similarly, in fourth vertex, 4 to 3 and 4 to 2. This is second situation. Okay, another situation will come, that is 3 nodes, 2 to 3 and 3 to 4. Similarly here 2 to 4, 1 to 4 is there, here remaining node is what? 3. Assume, okay, vertex, source vertex is 1, and now from here 1 to 3, 3 to 2, 2 to 4 will come. Condition is what? Person can starts his traveling, he must visit all the nodes. It's compulsory. Okay, and here in this situation, what are the values of which vertex will come? 1, 3, 4. Remaining vertex is what here? 2. And here 4, 3, remaining 1, 4, 3, remaining vertex 2. Okay, and here 1 to 4, 4 to 2, 2 to 3 will come. And so condition is satisfying here. Journey must starts from source vertex and visit all the nodes or all the vertices. And second condition is what? Must return same place. Must return same place. So starting point is 1, so it has to return which place? 1, first place. Okay, now in previous diagram 1, 2, 3, 4. Now consider this path 1 to 2, 1 to 2, 2 to 3, 2 to 3, 3 to 4, 3 to 4, 4 to 1, 4 to 1. This is one path. And come back to this one, 1 to 2, 1 to 2, wait, 1 to 2, 2 to 4, 2 to 4, 4 to 3, 3 to 1. This is second path. Okay, and take this path. I will write here 1, 2, 3, 4, because this one is very very important in this concept. 1 to 3, 3 to 2, here 2 to 4, 4 to 1. In this scenario, are you understanding? See, journey must starts source vertex and it is visiting all the nodes. Okay, it is visiting all the nodes. So here this is a concept. Okay, and now one more concept is there. Initial stage we have to mark, that is mod s is equal to 0. What we can call mod s is equal to 0, because there is no next nodes. I mean there is no next nodes, so that situation initially it is 0. Which one? S. Next stage is what? 1. Next stage is what? 1. See here, from 4 to 3, 4 to 3, 4 to 2. So how many stages? Only 1 stages. So that's why stage number is 1. 4 to 3, 4 to 2. Similarly 3 to 2, 3 to 4, 2 to 3, 2 to 4. This only one stage is coming na, so that's why we have to write stage number 1. In the next stage, see here, 4 to 2, 2 to 3. How many stages? 4 to 3, 3 to 2, 3 to 2, 2 to 4, 2 to 4, 4 to 3. How many stages? Yes, stages are 2. So that's why we have to mark mod s is equal to 2. Now s value is what here? 0. S value is what here? 1. S value is 2 in second stage. Okay. Now formula is there, that is, try to understand. Only in this problem you have to use these two formula. One is g of I comma q. I comma 5. This is called 5. Can represent like this, or pi means nothing. I repeat, 5 means nothing. Okay. I is what? I already told. C. C is cost. Cost in the sense two values, I and j. Obviously I represents rows, j represents columns. Okay. Now g of I value means 1, 2, 3, 4. What are these 1, 2, 3, 4? These all are cities. These all are cities, or we can call vertices or nodes, we can call. Initially value is null, so we go for this formula, C of I comma 1. What is the meaning? I of 1. I is row. I value is row and 1 is first column. While solving you will come to know 1 is first column. I is, you can take 2, 3, 4. Okay. In which situation? Mod s equal to 0. Is that clear? And second formula, J of I, S. S is what? Stages. Previous slide we have seen different stages, 0, 1, 2. So those values we have to fill in this place. Then C of I is a cost matrix, I value and j value, I through and jth column. So this is minus. Okay, you will come to know how to solve this formula, but you just remember these two formulas. Now assuming that starting city is 1, let us find the optimal tour. So s is equal to what? Null, means nothing, and find the cost as follows. See here, mod s equal to 0. In this situation, which formula you have to use? I already told, g of I comma 5. is equal to what? Which value I have to substitute? C of I first column. I means row. Okay. G of I comma Q, I comma Q or I comma phi, C of I1. This formula you have to use in which situation? When mod s equal to 0 means initial stage you have to calculate. So now in our example source node is 1, so we have to consider remaining nodes 2, 3 and 4. So I value is 2, source vertex 1 is a source vertex, no need to consider this one. Okay, it is initially null. Now you have to find out individually of these vertices cost. So 2 comma 5, 3 comma 5, 4 comma 5. So how to write this? I comma 5 is C of I1, 2 comma 5 is C. What is the I value here? 2. So this is I value, this is I value and this is I value. 2. I value is what? 2. This 1 is fixed. Why it is 1 is fixed? Because source vertex is 1, so we have to consider first column, so that's why it is fixed, no change. Okay, now how to take these values? Cost matrix. C stands for what? Cost matrix. What is the cost matrix? 2 to 1. What is the value? 2 to 1. What is the value? 5. So you have to write 5. And what is the cost? 3 to 1. 3 to 1. Third row, first column. 6. So you have to write 6. Fourth row, first column. Fourth row, first column. What is the value? 8. You have to write like this. Okay. And now next stage is what? Let us consider stage is equal to 1, or we can say mod s. Can say mod s is equal to 1. Because in previous video slide we have calculated mod s equal to 0. Next stage is 1. 1 means what? First node, mean 1 intermediate node. 2 can travel third vertex and fourth vertex. So this is how many stages are coming here? Only 1 stages. So that's why we have to mark stage size is 1. So we'll write like this. So what is the formula? G of I comma, there is a stage, so we have to write yes. Okay. Now G I value is what? Second. S value is, this is I value. 2 is I value, 3 is I value and 4 is I value. Vertex 2 can visit 3. Vertex 2 can visit node 4. Is it clear? So that's why we have to go for this previous slide. Why we have taken this, you will easily understand. Okay. 2 to 3, 2 to 4. So we have to calculate individually 2 to 4, 2 to 3 and 2 to 4. 2 is what here? I. 3 and 4 is what? S value. Okay. Now similarly we have to calculate 3 to 2, 3 to 4, 4 to 2, 4 to 3. So first stage, from which vertex to which vertex it has to travel, that we have to calculate. Okay, our aim is to find the minimum cost. So to find the minimum cost, we have to calculate all individual vertices cost. Now case number 2, mod s is equal to 1. Okay, means first stage, one vertex. 1 represents what? One vertex. Where should we write? In place of s. What is the formula? So g I comma s, this is our formula. Okay, now g of I comma s minimum c of I j, this is general formula, j s minus j. Now substitute this value. I is what? This, see, these all are I values. One is source vertex, so leave. I values are 2, 3, 4. Okay, I value is 2 and s value is what? S value 3. S value is 3. Okay, now minimum, how to fill this? C of ij, C, write down C as it is. I value is 2. J, what will write J value? J belongs to S, so S equal to J. That's why I have written S equal to J. J and S values are same, so 2 to 3. You have to write 2 to 3. Now here J value is what? 3. S value is what? 3 minus J value is what? 3. So write on S value is 3, J value is 3. S value is 3, J value is 3. Okay, now cost of 2 to 3. Refer cost matrix 2 to 3. What is the answer? 9. This 9 you have to write here 9. And now come to here 3 minus 3. 3 minus 3. How much? Nothing. That can say 0 or nothing. So how will write this? I will write g of g of 3 comma 5. So previously we have calculated g of 3 comma 5, g of 2 comma 5, g of 4 comma 5. That value you have to substitute. 3 comma 5, that is 6 value. 9 plus 6, how much? That is 15. So what is the cost? G of 2 comma 3 has the value 15. Is it clear? Now calculate another one is g of 2 to 4. You have to calculate g of 2 to 4. Minimum c of ij plus g, j comma s minus c. Now substitute these values. C of I value is what? 2. J value is 4 because j belongs to s. S value is what? 4. So 2, 4. J value is 4. S value 4 minus J value is 4. Okay. Cost of 2 to 4. What is the cost? 2 to 4? 9. Sorry, 10. So 10 you have to write. Now G 4 as it is. 4 minus 4, 5. 4 comma 5. What is the value of G of 4 comma 5? That is 8. 4 comma 5, 8. Then 2 to 4 is 10. So 10 plus 8, 18 is the answer. Next node is what? G of 3 comma 4. 3 comma 4 and 3 comma 2. First we have to calculate 3 comma 2. C of ij, apply the same formula. So substitute the values 3 2, g of 2 comma 5. 2 minus 2 is nothing, so you have to write 5. So substitute this previous value, g of 2 comma 5 has the answer 5. Cast matrix 3 2 2. And see here 3 2 2. What is the answer? 13. Just write here 13. Previously we have calculated 2 to 5, that is 5. 13 plus 5 how much? 18. So same way you have to calculate all the parts. Now 3 comma 4, what is the value? Substitute this 3 to 4. This is I value, this one is yes. Then j is also same. Yes equal to j I can write. Okay. Now 4 minus 4, 4 5. Then 4 pi value is 8. Cast matrix 3 to 4 is 12. So 12 plus 8 is 20. Now in next node, see one logic is there. 2 to 3. Here you can identify 2 to 3 and 2 to 4. 3 to 4, 3 to 2. Okay. Single vertex. Now 4 to 3, 4 to 2, 2 to, for one I value you will get 2 vertices. Because you just see the previous slide, you will come to know. Okay, now 4 to 2, ij 4 2, and yes, 2 minus 2 is how much? 5. 2 comma pi value is 5. 4 to 2, 4 to 2, what is the value? 8. 8 is there, so 8 plus 5, 13. Just write on this 13. Okay. Now 4 to 3, substitute this value, you will get the answer 15. Now next is stage number 2. Mod s is equal to 2. Here it involves how many intermediate nodes? 2 intermediate nodes. That's why we have to write 2. For example, I value is 2, 3, 4. S has how many? S equal to what? 2. So in previous slide S is equal to 1, but in this stage S value is how much? 2. That is 2 vertices, vertex 3 and vertex 4, vertex 2 and 4. 2 is there, na? So that's why we are writing S value is equal to 2. Just substitute these values in the same formula. Now why we are writing values like this? Because 2 to 3, 3 to 4. So that's why we have to write vertex 2 can visit third vertex and fourth vertex. So 3 comma 4. Vertex 3 can visit vertex 2 and 4. So 2 comma 4. Vertex 4 can visit node 2 and 3. So 2 comma 3. So you have to write like this. First S value is 0, then S value is 1, next S value is 2. First no vertex, first vertex, then second vertex, means intermediate vertices. Now case number 3, that is mod s equal to 2. 2 values. This is I, this one is S, and J value is also same. Now minimum, same formula, minimum C of 2 3. First we have to calculate 2 to 3. So 2 to 3. Next 2 to 4. So 2 to 4. Like that we have to calculate. Okay. Now J value is what here? 3. You just write 3. Now S values are how much? There are two S values. So 3 and 4. Write on as it is. Minus J value is what? 3. So 3. 3 sets are 3 comma 4 minus 3. So you just exclude 3 here. Exclude 3. What is the remaining? 4. So this 4 you have to write as it is. That is excluding process. Similarly here 2 4. I value is 2. J value is 4. I value is J value is 4. S value is two values 3 comma 4. 3 comma 4 minus 4. So exclude 4 here. Remaining is 3. Just write 3. 4 as it is. 3 you have to write. And the 3 as it is. 4 here as it is. Now identify this value. Cost of wherever C will come. So obviously go for this matrix. C of 2 to 3. What is the answer? 9. You just write here 9. And previous value we have calculated J of 3 comma 4. What is the value? Just identify and write here. And come to here. C of 2 here 2 to 4 is how much? 2 to 4, that is 10. 10 you have to write. And previously you have calculated J of 4 comma 3. That answer you have to write. 10 plus 15 25. 9 plus 20 29. So which one is minimum value? 25. 25 belongs to which vertex? This vertex. C of 2 4 means 2 to 4th vertex. 2 to 3 vertex. Okay. So answer is G of 2 comma 3 of and 4. Answer is 25. Similarly you just calculate 3 to 2 4. Just calculate 3 to 2 and 3 to 4. So this is your I value. This is S and J are same values minimum. So how will write? 3 to 2 first one, and J value is 2. Substitute this J value is here 2. S values are 2 comma 4. Then exclude 2 here. Exclude 2. Remaining is 4. You just write 4. Then identify this cast matrix. 3 to 2. What is the answer? 13. Just write down 13. G of 2 comma 4. Previously you have calculated. You just write that answer 18. So similarly same process apply and identify the minimum one. Your minimum is 25. Just write the answer. G of 3 2 and 3 to 4. Minimum cost is 25. Okay. Now 4 to 2, 4 to 3. I value is 4. S value is 2 comma 3. Then J value. Just write on yourself. Okay. Now the last step is find the length of our optimal tool. So in previously we have calculated okay, we have calculated intermediate nodes. Now we have to calculate the our whole journey. So from source vertex 1 to 2, 1 to 3 and 1 to 4. So in some examples they will directly taking this step. But what I have done simple from initial to last step I have taken. Okay, so here how we will going to apply the same formula you have to use. G of I comma S minimum C of ij, G of j S minus j. So G as it is, S belongs to what here? Sorry, I belongs to what? 1. S belongs to what? 2, 3, 4. I is 1. S values are 2, 3, 4. Now how will apply the logic? 1 to 2. See here, 1 to 2, one combination, and 1 to 3 another combination, and 1 to 4 another combination. Finally we will get the optimal solution for this problem. Okay, now C of ij, I value is 1 and j value is 2. I value is 1, j value is what? 2. Here j value is what? Obviously 2. Now S values are what? 2, 3, 4. J value is what? You have chosen only 2, so you have to write 2. Okay, now 2, 3, 4 minus 2. What is your job? We just exclude 2. We exclude 2. Just exclude 2. Remaining is 3 and 4. Just write 3 and 4. So C of 1, 2 plus G of 2, 3, 4. This is one sub-solution per sub-solution. Okay. And now another, again you have to calculate G of, this is what? 1 to 2 you have calculated. The next one is 1 to 3 you have to calculate. Now S value is okay 2, 3, 4. Now take the cost. J value becomes what here? 3. J value becomes 3 and 3. Then S value is same 2, 3, 4. J value is 3. So remaining is what? C of 1, 3. G just exclude. What exclude? 3 and 3. Remaining is 2 and 4. Just write 2 and 4. Okay, just write on in your notebook, you will come to understand. Now next, S values are 2, 3, 4 and J value is 4 now. Here J value is 4, S values 2, 3, 4 and J value is 4. You just exclude 4 and 4. What is the remaining? 2 and 3. Just write 2 and 3. Okay. Now consider this. G 1 to 2, 1 to 3, 1 to 4. You have calculated minimum path. Then how to find these values? See, you have already calculated this part in your previous slide, this part in previous slide, and this part in your previous slide. Okay, just fill those values and you will get the solution. Now see here. This previous value is 25 and 1 to 2 is what? 10. So you have to write here 10. This previous value is 25, 1 to 3. Now in this example 1 to 3 is 15. You just write here 15. This one is previous value, that is 23. Then 1 to 4, 1 to 4 is 20. You just write 20. Now add this. 10 plus 25 35 and 40 and 43. Our aim is to find the minimum value. What minimum value? That is 35. So write down 35. This is your final solution for the TSP problem. And next one is we have to draw a path. That's it. To draw a path, I am considering that situation 35. With the help of this equation only we have got 35 na? So that's why we have to write. Now how to draw path? See here, cast up 1 to 2. This is represents 1 to 2. So just to write 1 to 2. 1 to 2. Now G up 2 comma 3 to 4. So you have already calculated this. Use that equation. See here, G up 3 comma 2 3 4 3 4. Calculated two values. Minimum value is 25. This 25 belongs to this equation. Is it clear? See here, this equation. C up 2 4 plus J up 4 3. So you have to write here. Below this you have to write C up 2 4 plus 4 3. Okay. Now written. Now you are getting cast matrix value. Okay, 1 to 2 already written. Next vertex is what? 4. So you have to write 4 is 4 only. 1 to 2. 1 2 means 1 to 2. 2 4 means 2 already written. Next vertex is 4. You just write 4. Now this previous value you have to consider. G of 4 comma 3. See here, 4 3 plus G of 3 comma 5. 4 to 3. Already 4 is written. Next vertex is what? 3. So 4 to 3 you have to write. 4 to 3. Now here 3 comma 5, initially 3 to 1 will come na? So 3 to 1. So 1. Now in this example, a path can travel 1 to 2, 2 to 4, 4 to 3 and return back to the source vertex. Okay, so the total cost is how much? 35. So in this way we have to get the optimal solution for TSP problem. Okay, that's it. Thank you.